All right, what up, pre-calculus students? We got a new lesson on the law of cosines. So, law of cosines is used if we have a certain situation with a triangle where you're given an angle and the two kind of adjacent sides, or if you're given a triangle and you just have all three sides. I'll keep it the same. B, C, A. The problem with these situations is like you want to use the law of sines, and you know that the law of sines was all about having an opposite angle and side length kind of pair that you use to kind of help you find, and also use the fact that all the angles add up to 180 degrees. Well, I don't have opposite angle, opposite side length pairs. And if I wanted to try to find one, I just wouldn't be able to using the law of sines. Here, I don't have any angles, so I don't have any angle side pairs. So I need something new. Okay, and this is a new kind of law, the law of cosines. I'm going to show you where it comes from. And it actually comes from the Pythagorean theorem. Okay, so here's a triangle, and I'm going to call this A, this is B, and this is C. And like we did with the law of sines, I'm going to split this into some right triangles. Okay, so now I have right triangles. What I'm going to do is call this distance x, and this distance is from here to here, which means if this entire side length is a, this distance from here to here would be a minus x. Okay? Now, let's use the Pythagorean theorem. Let's call this an h. Okay? And let's just write the Pythagorean theorem for both of our triangles. You guys could probably figure this out and do this yourselves. Let's start with the easier triangle here because it's x, h, and c. So I have x squared plus h squared equals c squared. And that's a tiny c, that's the side. And let's write it out for a minus x, h, and b. Okay. So I have a minus x squared plus h squared equals b squared. Okay. Now, this a minus x, I feel like I can simplify it. So I'm going to go ahead and square a minus x. Now, make sure you understand why it's going to be what it is. You write it as a minus x times a minus x. You distribute everything, and you get a squared minus 2ax plus x squared. And I still have the h squared, and I still have the b squared. Okay? Now, what's interesting here is like we got some things that are the same here. I got some x's, I got some h's. And I'm going to go ahead and get rid of x first because it's going to be something that we want to remove if I just want some sort of formula that uses a, b, and c. So let's get rid of x first. So I have h squared equals c squared minus x squared. Sorry, I said get rid of x first. So let's solve for h. Let's solve for x. X squared equals c squared minus h squared. I just subtracted h squared from both sides. So if this has to be true, this has to be true, I could take this and plug it in for x squared. Okay? So I get a squared minus 2ax plus, instead of x squared, I'm going to replace x squared with c squared minus h squared. And then watch what just happened. Naturally, when replacing x squared with what it's equal to, using the Pythagorean theorem from the other triangle, I have a negative h squared and a positive h squared. The h squareds are gone, giving me a squared minus 2ax plus c squared equals b squared. Or I can write it as a squared plus c squared minus 2ax. Now, I want to get rid of x because, like, x can be anything. So I'm going to use a trig, a SOHCAHTOA situation where I know what x is. So let's see. I have this angle B. I want to get rid of X. Well, I know B is adjacent with X and C is the hypotenuse. So over here, I'm going to just write, okay, well, I know that the cosine of B equals X over C. Okay? Well, watch that. I can just multiply both sides by C, and all of a sudden, I've gotten rid of B. I've gotten rid of H, I've gotten rid of X, and I just have A's, B's, and C's. A squared plus C squared minus 2AC cosine angle B is equal to B squared. This, my friends, is the law of cosines. That's it. This is our new formula. Let me try to throw it at you so it makes sense. Okay. What you're going to see is you're going to have this like trident situation. You got an angle and opposite side A, adjacent side C and B. What we're going to say is this is the side length that we could potentially solve for first. A squared equals C squared plus B squared, or B squared plus C squared, minus 2BC times the cosine of angle A. So it's using these three, we'd be able to find that. And then we can use the law of sines after that. Let's say you want to find angle C. Law of cosines can look like this. Okay, we got opposite, we got adjacent, adjacent. Here's the formula that this would look like. C squared equals A squared plus B squared minus 2AB cosine angle C. Okay? And then here I have the B squared solved for. Let's see if I wanted to find angle B, and let's say I used angle B, you'll see the formula that we just created. Start with your like, trident here. Boom, boom. This is the one that is equal to, you see B squared equals, I'll write A squared first plus C squared minus 2AC cosine angle B. That's B squared equals A squared plus C squared minus 2AC cosine B. Okay, so that's the law of cosines. The law of cosines coming from the Pythagorean theorem in a oblique triangle using two right triangles. Okay, all we need to be able to do is set up the triangle and then set it up with the law of cosines, and then we'd be able to solve for either an angle or a missing side length, and either use it again or use the law of sines to find another missing angle. So let's see this. I got Q, R, and S. 18, 21, and 27 looks to be right. Now, it's up to you what you want to find, uh, but you're going to have to start with finding an angle. Cosine, if we're using inverse cosine, cosine's positive in the first and in the fourth quadrant. Typically, your calculator is going to give you an angle in the first, but if it gives you the angle in the fourth, it's going to show up as negative, which means what's safe is to find your smallest angle, an acute angle first. You have two acute angles and potentially one obtuse angle. Uh, Let me think about an example. I mean, It's going to always give you the one in the first quadrant or the fourth quadrant. And you'll have a negative angle. It might confuse you. Let me just say it's safe to find the acute angle first. Let's see while we do a problem. Now, what's going to be the smallest angle? It's going to be opposite the smallest side. So if this is 18, angle Q is going to be the smallest. Okay. Now here's how I set up the law of cosines. I kind of use my little trident to help me. This is what starts out as my first value. This equals this squared plus this squared minus 2 times this times this times the cosine of Q. Okay, so 21 squared plus 27 squared minus 2 times 21 times 27 times the cosine of Q. Now I can find this angle Q by just solving for cosine. I'm going to have to do a little bit of arithmetic. I have to do a little bit of calculator work. I got 18 squared, 324. I can do 21 squared plus 27 squared. This is 1,170. I can do 2 times 21 times 27. 1,134. And that equals the cosine of Q. Okay? Oh, guys, never mind. You can never have an angle here. If you ever get a negative angle or an angle in the fourth quadrant, that angle is going to be bigger than 180 degrees. Can't exist in the triangle. Law of cosines is safe. It's safe to use for any angle. It doesn't even matter. You can find any angle. Law of cosines will always give you this first angle. If you ever get the negative angle, which you probably won't, just make sure you find this positive angle in the first quadrant. We'll see if that ever shows up. I don't think it will, but this is going to be easy. This is going to be easy. We're just looking for an angle in the first quadrant using the law of cosines, or it'll end up being in the second quadrant, which is fine. You'll see when we use law of cosines, if we get a negative value and inverse cosine at a negative value, you get this angle in the second quadrant. That's good too. What we don't want is an angle that's between 180 and 360 degrees, because then it won't be in a triangle. Triangle angles have to be less than 180. All right. Anyways, you'll be fine. Now we solve for cos Q. I'm going to take that 324. I'll subtract 1,170. I have negative 1,134 cosine Q equals 324 minus 1,170. That's negative 846. I'll then divide. So divided by negative 1,134. And I get 0.746. So this is what the cosine of Q is equal to. 0.746. We will use inverse cosine to find angle Q. Now let's see what happens. Inverse cosine of that 0.74. Boom. 41 degrees. I feel good about this. The other potential would be 360 minus the 41. Not going to be in my triangle. I don't have to worry about that whole ambiguous situation when using sine. So 41.752. Now, because cosine, inverse cosine will always work, and it's always going to give us a nice angle, it's actually safest to use inverse cosine and to use the law of cosine when finding angles. If I use law of sines, I have to have that situation where I'm looking for angles in the first and potentially the second quadrant, which sometimes gets confusing, and you have to do a lot of things, a lot of checking of things. So if you start using the law of cosines to find angle, it's probably safest to find the other angle, another angle that you're missing using the law of cosines. I know that I now have this opposite Q 18 relationship. I could use the law of sines now, but because of the whole sine could be in the first or the second quadrant, it's safest to use inverse cosine. So let's just find angle R, which will be right here. I'm going to set up the law of cosines using angle R. Once I find angle R, I have angle Q, I'll be able to find angle S by subtracting them from 180. Okay, so set up your like trident situation. We got opposite. This is the one that's going to be on the outside. So I have 21 squared equals 18 squared plus 27 squared minus 2 times 18 times 27 times the cosine of capital R, angle R. Do some math. This is 441. This is 1053. This is 972. 441 minus 1053 divided by negative 972. And I get cos R equals 0.629, dot, dot, dot. Inverse cosine that. You get 50.977 degrees. Okay. Now that I have Q and R, I can find angle S. 180 minus 50 minus angle Q was the 41 degrees. So let's find that 41 angle. There it is. And my third angle is 87.27. Now watch this. I can kind of check that I've done everything correct. Let's do the law of cosines with S. Okay? And let me just show you how like it's actually safe to use the law of cosines to find angles no matter what. So if I start with S, my trident situation's like this. I'll do it up here. I'd have 27 squared. The opposite, the angle you're trying to find is the one that goes by itself, equals 18 squared plus 21 squared minus 2 times 18 times 21 times the cosine of angle S. And I'll just do this really quickly. 27 squared minus 18 squared plus 21 squared, subtracting both of those, divided by negative 2 times 18 times 21. Inverse cosine that number. This is just me solving really quickly. 87.27, boom. Okay, so like inverse cosine works. Inverse cosine works. You don't have an ambiguous situation. You don't have to worry about law of sines in 0 to 180 and two angles. Inverse cosine will always give you the correct angle, whether it's in the first quadrant or the second quadrant. So that's nice. All right, now if we have a side angle side, let's see how the law of cosines works here. I'm going to say this is Y, this is 62 degrees, this is X, this is Z. So I have this like side angle side relationship. I set up kind of my trident where it's like, okay, this side length Y, that's opposite my angle. With law of cosines, you set it up so your opposite side length is like by itself. It really is just a squared plus b squared equals c squared, just with a little bit extra because it's an oblique triangle. So 12 squared plus 9 squared minus 2 times 12 times 9 times the cosine of my angle, 62 degrees. This is going to be easy. Y squared equals 12 squared plus 9 squared minus 2 times 12 times 9 times the cosine of 62. Enter. Don't forget to square root. You don't have to worry about the plus or minus. We're talking about triangles, side lengths we want to be always positive. 11.117. Okay. Now I found y. So that's good. I need to find another angle. You do have an opposite side angle relationship. You could use the law of sines, but then you'd have to use inverse sine, and then that's going to be a little bit tricky. So, what's safest when finding angles is to use the law of cosines. So, this is angle Z. I know that this is 11.117. I'm going to use the law of cosines to find angle C. Okay, ready? Here we go. I have 12 squared equals 9 squared plus this 11.117 squared. Make sure you use the entire decimal. Minus 2 times 9 times 11.117, that number, times the cosine of Z. Let's do the math slash the arithmetic. 12 squared, 144. 9 squared plus 11.117 squared, using that entire number, 204.59. 2 times 9 times that 11 number, 200. Cosine Z, we'll solve 144 minus the 204 divided by the negative 200. 0.3028 is the cosine of angle Z. Inverse cosine always gives you the right angle. You don't have to worry about potential other angles because your other angle would be in the fourth quadrant or in the third quadrant, which can't happen because triangle angles have to be between 0 and 180. So that's angle Z, degrees. And now I can find angle X. 180 minus the 2. And if you use the law of cosines, you'd get the same angle. 180 minus the 62 minus the 72.37. 45.625. Now, you want to check using the law of sines? Sure. The sine of x over x has to equal the sine of z. What was z? 72. The sine of z over z, 0.0794. Boom. Okay? Boom. Everything works out. The triangle's correct. I could also check with y and the sine of y. We're good. Okay? And that's it. That's the lesson. Trident. Set up your formula correctly. It's just the Pythagorean theorem. Always set it up. You can either solve for an angle or you can solve for a side. Do your homework. You might have time to do it for the rest of the class. If it's done, great. We'll do a couple practice problems, but this stuff isn't too tricky. You just have to be neat and orderly and not make any calculator mistakes for the most part. All right. I'll see you guys on Monday. Later.